Charlton, make sure you adjust your video so that you are in. Okay, can I see your tie? Okay, so what we are going to do, okay, I will actually look into what you have learned in the previous lesson. So now I'm going to actually send you a link in your chat box. Please see the chat box. I will send you this link. So what you need to do, you need to click at that link and you will be directed to Nearport. Okay, use your name and start writing 3 things that you have learned in the previous lesson. So we will do that in 3 minutes. Okay. So please do that now. So we want all of you to be there. Okay, so far only 2 of you. So you need to actually write down, okay, what we have learned in the previous lesson. Hurry up. Just recall any 3 things and then write down over there. Charlton, is everything okay? Okay, good. Yeah, good, good. Okay, I can see your response over there. Hurry up, the rest. Hurry up. Okay. Okay, no need to write the same thing. I can see you wrote about sampling and continuous. Okay, so can you actually recall about, okay, what are the examples in sampling and continuous? Okay, Jody, good. Hurry up, Arnetta, no response yet. Calorimetry is supposed to be colorimetry, Arnetta. Yeah, Lavi is correct, colorimetry. Colorimetry is going to be used to detect the change of color. Okay, Shane, sampling takes small sample of reaction at various time. Good. Dilatometer. Good. Janice, dilatometer is to measure the change in volume. Sampling involves small sample. Good. Dilatometer. Electrical conductivity. Yes. Charlton, very good. Good. Okay, sampling involves chemical analysis. Very good, Janice. Okay, good, Justin. Shane, very good. You mentioned about gas range. Okay, Nicole Tricia mentioned about sampling requires ice to slow down the reaction. This is going to be known as what? Nicole Tricia, can you write down? This is known as what? Quenching. Good. Gabriela Lavi, good. Quenching. Okay, very good. Janice. Okay, good. Okay, good. I think it's good enough. Okay, you can actually go back. Okay, chemical analysis. You can come back to the main room now. Okay, enough. Okay, I can see all the same things over there already. Okay, good. Okay, we will go back to the main room. So here, okay, we actually recall about what we have learned in the previous lesson. So in the previous lesson, we have learned about rate of reaction and what are the methods that we can use to identify rate of reaction. And we came across two examples, and you have mentioned those very clearly over there. So that is the part that is going to be what we have learned in the previous lesson. Now, so what we are going to learn today, okay, today we are going to learn about calculating initial rate and rate at specific time using concentration against time graph, rate equation and order of the reaction. We are going to construct and use the rate in form of this rate equation. And then we are going to deduce order of reaction by using two graphs. Okay, we will actually discuss the two graphs later. But I have given you a video yesterday, okay, and I told, and all of you have verified that you have watched that video. So this information of this video, we are going to actually use for this activity 1 to activity 3. So I've given you the worksheet just now, okay, all of you should have that worksheet. So what we are going to do, we are going to actually assign you into breakout rooms, and this activity will be for 25 minutes. And I will also assign the teachers also into the breakout rooms. And you are going to use the knowledge that you have in the video, okay, to complete activity 1 to 3. Active discussion must take place. So team leaders, you need to actually submit this. You can share your screen, okay, and you can write down. Each of you have, I've assigned so that you have the Apple Pencil. You can lead the discussion. And later, when you come back, you are going to be assigned random activities where you need to present to us. Okay, so I'm going to open the rooms now, okay, and you will be going to the breakout rooms now. Charlton, join the breakout room.
Don't have the link.
Oh, okay. Okay, join now.
Look, he shares screen.
Apa aja?
Worksheet activity 1 to 3.
Yeah.
Okay.
I think we have to do activity 1 first. Activity 1, 2, and 3. You guys see my screen now?
Yeah. Can.
Okay. Let's start with number 1. Discuss on above the two graphs. Explain what line B means and how line B is constructed. Okay, so this graph is probably just an extension of this part, right?
Yeah.
And then they ask what line is this? What do you think, Charlton?
The initial rate.
Initial rate, yeah. Okay. Because this is a tangent. Because this is a tangent of the graph here. It means it's finding the rate of reaction from here, right? So this is the initial rate of reaction.
Yes.
Yeah, activity 2.
Yeah, activity 2.
You go up. Yeah, that one.
Wait.
Wait, isn't it that one activity 1? Tapi kan have A and B, yang B, right?
Yeah.
You need to do activity 1, 2, 3. Yeah. Shane, you should go up.
Oh, kita discuss.
Yeah. B is the tangent way.
Okay.
Last time we go up.
So I write here. Lalu can you write?
Have the question below. For
But
A,
this
compare
activity
this graph and the graph in activity 1.
Yeah.
But activity 1, we have to write first the line B.
Okay. So line B is the
Activity 1
tangent.
We need to do the graph.
Yeah. It means it's the rate of reaction dong, if tangent.
Yeah. Kan mole over time.
Yeah. So it means line B is the tangent.
So I reckon
Yeah.
line B, tangent
Yeah,
and rate of reaction, yeah.
and shows the rate of reaction.
Initial. Udah, right? Then
question
kalau SQL ini ke bawah juga weh, the answer.
Ada di aja. We can already write down. Okay, activity 2.
Okay.
Compare this graph and the graph in activity 1. Yang
Okay,
ini
let's go.
increasing ya kalau nggak salah.
Decreasing gradient.
Yeah.
Gradient so it's less steeper.
More negative, right?
More negative.
So more negative ya?
But we cannot see
just say
calculate.
We say one increasing, one decreasing.
Okay. Yang activity 1. Increasing ya?
Activity 1.
The tangent is
Yeah.
yeah.
Okay. It's right here. Activity 1.
I think we need to put like decreasing and increasing, I guess. Should we?
Sure.
So activity 2 shows decreasing gradient, right?
Yeah.
So that means activity 2 shows the decreasing rate of reaction, right?
Is that increasing?
Wait. It's increasing. Activity 2 is increasing, right?
Yeah, increasing.
Like,
I think let's actually focus on just comparing, guys. Compare, okay, so then move on. Okay, don't waste time.
Okay.
Okay, so now B, yeah.
Wait, so activity 2 is decreasing or increasing gradient? It's
activity 2 increasing, like that. So let's see. I'm not sure.
Okay, let's see. Yeah. Okay, so like for example, here and here we have, and then compare with this and
I think
yeah.
I think we just need to put increasing concentration and decreasing concentration, I think. Something like that.
But it affects with the gradient because gradient is the okay lah, no need lah.
Because the gradient in the first one would be like kind of like slow down after the first part. Both of them will decrease.
So activity first is decreasing, right? Tom is right?
I think in both activities, it will slow down. The rate will slow down.
Where you want to go, sir?
Bring me, yeah, up to you, sir.
Okay, I'll just put into, just now you were in Shane's group, so I will put...
Shane, yeah. Then maybe the other Mr. Rufus and Mr. Shane,
Yes.
bring them to other also.
Okay, you can go.
is plotted against rate of reaction and concentration.
Mm.
Then what's the gradient? So it's a gradient. It's a gradient.
Oh,
so
yeah,
it's constant. Yeah.
Okay.
Next.
Okay.
Yeah.
There are three types of rate of reaction, rate of concentration graph. Using the information in the videos and earlier, draw all the shapes the graph against the concentration.
Ini apa? Rate over concentration.
Increasing nggak?
Increasing. Karena
In the video, because this one in the graph above, it's concentration against time, right? But this one, if it's rate against concentration. So it's like the opposite.
So the gradient will be increasing.
Yeah.
Gradient increase ya?
Yeah.
Okay. There are three types of rate against concentration.
Using the rate against concentration.
Tadi tuh.
The straight line, the horizontal one.
Guys, sorry to stop you. Just now you mentioned about gradient increasing.
Yeah, for A.
You see properly if a graph of rate against concentration is plotted, what can you say about the gradient? The gradient is going to be rate over time. Shane, can you go down, show the table? Show us the table, Shane.
This one?
Yeah, you can see the table over there. The gradient is supposed to be if a rate divided by concentration, and the gradient is same as the 6.67 over there, right? Lavi?
Yeah.
And there is actually 6.67 is the same number being repeated 3 times there. So what can you say about the gradient?
So constant.
Yeah, the gradient is constant.
Oh, that one is this. This one is rate over time. Rate over concentration.
Kalau rate over concentration yang tadi kan. It's increasing or decreasing the gradient? I think increasing.
The gradient is
the second order.
Like this?
Yeah, I think so.
Okay. Next ya.
Yeah.
The second.
Then please label the graphs properly.
Oh.
Yeah.
Now
So
we
you need to do
label.
until activity 3 only, yeah? Activity 4 wait.
Okay. Label, kan udah di label.
First order.
Order.
And then the team leader, Shane, make sure you get this sorted out. Okay, write down properly. Then you need to actually email to me.
First order yang kayak straight line gitu.
Yeah.
Okay, next.
Up to activity 3 only. Okay, so please actually write down all the answers. Then you can actually send it to me, the team leader. Team leader for this will be Aneta, right? So Aneta, then if you are done, you can leave the room and you can come to the main room.
Wait, is it okay if our answer is really short?
It's okay like this?
Okay.
Mr. Sheikh, I'll close the breakout room now. Yeah.
Okay.
Hi guys. Okay, so I hope that you had a very good discussion. Okay, so we will actually start to discuss whatever things that you have discussed earlier. Okay, so we will actually discuss it now. So what we will do, okay, we will start with activity 1. I've assigned different groups, okay, to discuss. So activity 1 will be discussed by Shane. Okay, so Shane, you can assign anyone, okay, not necessarily will be you. You can actually share your screen and you can actually discuss what you answered for activity 1 now. Yeah, go ahead, Shane.
So I share my screen or
Yes, you can share your screen now.
wait, sir, I think.
Yeah. Or if you don't want to share, Shane, it's okay. You can actually just answer us directly over here. I have it on my screen.
Oh.
Discuss about the 2 graph. What can you say?
Line B is the dimension of the graph.
The others can also help the members of the team.
So the gradient shows the rate of reaction.
So what is
And then
actually, yeah, go on.
The second graph show the initial rate of reaction.
Okay, how do you know that it's initial rate of reaction?
Because it's when the graph is still like straight line, and yeah.
Not enough. I think it's just we draw a tangent so that you pass through the only one point at 0.00. Yeah. So that is going to be the initial rate of the reaction. Okay. You can actually find out more in the video that I actually gave you yesterday. Okay. So is there anything else you want to add, Shane, and your group members? If I ask you this graph, okay, propene is most likely reactant or product? Shane?
Product.
Are you sure?
Product.
Are you sure? Just someone say yes. Finish already. Okay. Why? If it is yes, why? Why is actually product? Why you say it's product?
Is it because the concentration increases over time?
Yes. Initially at time 0, there's no product. And then now you have more product until to a certain concentration, it starts to slow down. Yeah. Formation of the propene is slowing down. So anyway, so we will move to Arneta's group. So Arneta, okay, we will go for your group, okay, activity 2. So there's a lot of question over there. Arneta, Victoria, Nicole, Trisha, and Janice, you can actually help. I will share my screen. If you want to share your screen also, you can do that. So Arneta.
So activity 2A, we said that graph, we showed that the activity 1 is the graph that shows the product and activity shows the reactant, and then
okay. So how do you actually
For-
calculate the rate of reaction at time 10 minutes?
We draw a triangle to find the gradient that shows the rate of reaction, and we got -6. We got -6.67.
Okay. So C, can you move on to C? So maybe C, maybe Victoria can take over. C.
For C, it's the product.
Okay. If it is, are you sure it's product? Because if it is a product, are you sure the product will
reactant,
decrease?
reactant.
Yeah. So Victoria, so this one is going to be product or reactant?
It's reactant.
Why you say it's reactant?
Because the rate slow down, right? And then the concentration also decreases over time.
Yeah, because it starts from like somewhere, the concentration is 1.5, then they actually decrease. Okay, so it means the reactant, this is reactant that is being used up in this reaction. Yeah. Now, D, use your knowledge from the video shared, okay, to other shapes of graphs. So maybe this one, I think Arnetta, you can share your screen to show us concentration against time graph.
So we didn't actually draw.
Okay.
We
So
did.
if I
we only wrote
actually help out, okay, let's say if I help out, so this one is going to be concentration against time. So what is going to be the first graph?
We drew steeper and
Again?
we draw a steeper graph compared to the one in the activity 2.
Okay, so there is one like this. So you draw a steeper one. Okay, so another one.
Yeah, and one constant line
Okay,
graph.
another one is
Linear.
like something like this. Okay, so these are the three graphs that you can get for concentration against time. Are you sure?
No, ghost answer.
The first one, this one is wrong. Yeah, so which one? So how
It's a
it's
straight
supposed to go?
line.
So it's supposed to be, am I
Yeah.
correct? Yeah. So
Yeah.
take note, okay, take note. If you have a constant line graph like this is going to actually for rate of reaction. Okay, rate of reaction is being constant gradient. So in this case, you are going to have three types of graph. Yeah. So let's actually move on to the last one. Okay, this one is going to be Jody's group. Okay, Jody, Justin, maybe you can actually take over first.
Yeah. So can I share screen? Should I share screen?
Yeah, you can. Can you share?
You're sharing the screen.
Okay, I'll stop sharing first. Okay, you can do that.
Yeah, this is for activity 3 for me, Jason, Chapman, and Jody. So for A, they're asking if this graph is changed to a rate of reaction against concentration graph. What's the gradient? So we looked at this part of the table and said, okay, so this is the gradient and it's constant. So the gradient of the graph should be constant. Secondly, they're asking about the three types of rate of reaction graphs. So we just put the zero order, first order, and second order graphs. First order should be just a straight line.
So in this case, Justin, which this graph represents which graph that you have drawn over here? Is it first zero or second order?
Should be second order.
Are you sure? Because here is actually the rate is constant. So which of the graph will be representing out of these three graphs, which of the graph will be suitable to represent this particular graph?
First order.
Yeah, first order. Why?
Because the because the gradient is constant.
Yes, good.
And also
Okay.
the concentration and duration is increasing.
Yeah, very good. Okay, very good. So now I will share my screen now. So the team leaders, make sure you actually email me. Okay. I will share my screen. So now we actually will go to activity number 4. Okay. Now for this activity number 4, you are going to go back to your breakout rooms, but we will actually discuss this very fast. Okay. It's investigation about the rate equation. So we will maybe take less than 5 minutes. Okay. So I will open the breakout rooms now. So you will join the breakout rooms now and discuss activity 4 only.
Udah bisa lihat.
Okay. Read first aja, just read first.
Theory. Discuss. M10 in the rate. The gases only.
Okay, so I think we can do this number 1, 2, and 3. For number 1, rate of reaction always involves all reactants in the stoichiometric equation. This should be no, right? Because for number 2, if you can see, this only rate of reaction only counting the nitrogen oxide, but reactants have carbon monoxide and oxygen, so should be no, right? Okay, number 2, MNN and rate of blah blah are found in stoichiometric number on front of the equation.
Maksudnya apa sih?
It means this number over here is same with this number over here, but this is 1, right? This is 2, so I should be wrong, right? But I'm also conflicted because this is also 2, but this is also 2. But this also have 2. This has nothing also. So should be no.
Nggak tentu kan?
Yeah. Rate of reaction always calculated based on concentration of the gas only.
Wrong also.
You want to go to different rooms, sir?
Yeah.
Just now you were with okay, Arnetta. So I'll put you to Shane.
Number 4 they've done already.
Yeah, I'm going to close the group also. Okay, guys, I hope you had a very good discussion just now. Okay, this is very interesting activity. Okay, because we are discussing about rate equation. I have not taught you about rate equation, but you should be able to use the examples that is given over here to find out, okay, whether, let's say, Charlton, I chose Charlton over here. So the statement that is given by Charlton is correct or not. So since Charlton is there, maybe Charlton, can you actually tell us rate of equation involves all the reactants in the stoichiometric equation? Is that correct?
Wrong.
Okay, wrong. Why?
The second one only count the nitrogen monoxide.
Yeah, so like for
But
example,
the rest also.
yes, okay, carbon monoxide and oxygen, they are not counted for the number 2. Okay, so M and N in rate are found from the stoichiometric number in front of the equation. So Victoria?
It's wrong, sir.
Okay, it's wrong. Can you tell us why?
We use the reference from example number 3.
Okay, so if it is 2, okay, it's not 2 here. Okay, this one is 1. Okay, so in this case 2, then it's 2. So it's not always correct, so it's wrong. Okay, rate equation are always calculated based on the concentration of gases only. So Janice, can you tell us, is that correct or wrong?
Wrong, sir.
Why?
Because based on example number 4, it's all aqueous.
Okay, based on number 4, okay, so it's aqueous, yeah. So this one is aqueous, okay. So it doesn't mean that they are gas, they are going to be aqueous, will be connected and so on. So in this case, now I'm going to actually show you something over here. Okay, rate equation. Let's say, for example, if you have cyclopropane to change into propene, okay, the rate equation can be written as K. This K just now we have written as rate constant. Okay, it's a rate constant. Then we times with this cyclopropane, which is one of the reactant over there. Now this reactant, okay, the K is the rate of constant. Now this equation that we write, the rate equation, all these rate equation cannot be just determined by the equation. Okay, cannot just simply refer to this equation. You can only determine the rate equation using experiments. So this is very important. You need to use experimental data to come up with this rate equation. And all these values that you have, okay, the M and N values over here, the 2 and so on, all these do not come from the stoichiometric equation. It comes from the experiment as well. So later we will look into how to use the experiment. Now, anyway, okay, if you have, there is something what we call as order of reaction. Order of reaction means, okay, you have already learned about this order of reaction. We have 0 order, first order and second order, okay? And sometimes they do ask you what is the overall order. The overall order is, like for example, for this example, if you have like 1 and 1, the overall order is 1 plus 1, which is the overall order is 2. What is the overall order for this reaction? Then it's 2. So Charlton, what is the overall order for this reaction?
3.
Good. Okay. 1 plus 2. Okay. And Arnetta, what is going to be overall order for this reaction? Arnetta, can you hear me? Okay, Shane, can you actually help out? Arnetta's
4.
Yeah, it's 4. Yeah, her connection is. Now, so what I'm going to actually tell you again here, okay, that is going to be the order of reaction. So we have done the order of reaction, okay. So it's the power, okay, to the concentration of the reactant in the rate equation. And do remember this one, we will, not so important, but do remember overall order or any order of reaction, they can be also in fraction. It can be also in 1.5. It's not must be 0. It not necessarily will be 1, 2, and so on. It can be in fraction form as well, but it's not so important. But now I will also go through, okay, the part for units. Okay, you can actually calculate the units of K. K is the rate constant. So you can, if you look over here, okay, rate, okay, we should know that rate is going to be mole per dm cube, okay, and then per second. This is rate, okay. And if I want to find the K, okay, for this example, okay, it's supposed to be rate divided by this. You can calculate what is going to be the unit of K. Okay, you will have this unit. So what I'm going to do, okay, now we will actually assign you, okay, no need to go into the breakout rooms. You are still going to be, okay, here, and you are going to do activity 5 and 6 on your own. Okay, 5 and 6 on your own until I stop you. Okay, so probably we'll take about 3 minutes. Activity 5 and 6. Please do activity 5 and 6. Okay, anyway, I have to stop you now. Okay, you can actually look at some the examples that I have written over here. Okay, calculating the units of K. Okay, you can calculate the units of the K over there. Okay, like for example, let's say if I show you for B, okay, rate is proportional to the square of hydrogen iodide. So you just need to put rate. Okay, then put the rate constant over there, and then hydrogen iodide. Okay, it's going to be proportional to the square. Just put 2 there. As simple as that. Okay, and then for if you want to find the unit for K, so here I have actually write down the formula for the rate. The formula for rate is going to be change in concentration divided by time, one of the formula. Yeah, so in this case it's going to be mole dm93 per second. So here we will use this unit, okay, for the rate. This is going to be the unit for the rate. So just use the unit and then find the value of the K, not the value of the K, the unit for the K, where this one will be divided. You can cancel and then you will get this. Okay, please practice this on your own. Okay, the answer key for this is inside the PowerPoint that I've shared to you earlier. Okay, because of lack of time, okay, we will not actually open the breakout room for this. Okay, anyway, okay, this activity 7 will not be a breakout room, but you see over here, we have discussed about this earlier. If you have a reaction rate, you can have 3 types of graph. One is going to be the 0 order, and you can have a second order. They will follow the something like a quadratic graph. Okay, so R to the power reactant to the power of 2. Okay, so it's a quadratic graph, and this is going to be a straight line graph, which is going to be directly proportional graph. So it's a straight line. Okay, so this is going to be, you need to know about this graph. Okay, if let's say we are not going to go into the breakout room, we are going to try to sketch this graph. Okay, so now, okay, Lavi, can you help me out for A, how to sketch the graph rate against concentration? Take note, rate against concentration. So this is concentration of NO. So what do you think the graph, how will it look like?
There will be a straight line.
Which one?
Will there be a straight line?
Are you sure? It's to the power of
Wait,
2.
it's the second order, so it's
Which
going
one?
to be the second order. Like
Yeah, so
quadratic
which is a quadratic graph. Yeah, you can see it's a quadratic graph. So it will be something like this. Okay, Jason. So if you have rate, if I erase this part, okay, this is going to be B, for example. So Jason, what graph will it be? If I put it as number 1, 2, 3, which one?
1.
Number 1, yeah. So it will follow like this, okay, where rate is going to be constant, the K. Okay, that's going to be for B. For C, okay, for C, so C, Gabriela, Nicole, can you help out with this?
A straight line from the 0.
Yes. Okay, why? This is what order?
First order.
Yeah, it's a first order reaction. Okay, so that is going to be activity 7. So here, so let's say if we want to summarize the lesson today, okay. So Shane, can you actually summarize what you have learned today?
About the graph, rate over concentration. Concentration over time also.
Okay, what else?
And,
maybe, yeah.
I forgot that one.
Yeah. Okay, it's okay. We'll actually ask Charlton. Charlton, switch on your video and then answer. Did he go to the toilet? No. Okay, Charlton, can you summarize what you have learned today?
The types of graph. The observation just now.
Okay.
Units of K.
Okay.
Sampling vs continuous.
Okay. What else?
Done.
Done. How about initial rate? Did you mention about initial rate?
Oh yeah, that one also.
Okay. So now, okay, I'm going to actually see how you how well you understand the concept. So I'm going to actually share you another Neopod link. Okay, I will share it in the chat box. Okay, and then you are going to actually join like just now. Okay, make sure you write your name, okay, before you join. So I will share it to you now. So it's going to be some questions, 8 questions over there. And we will wait until everyone join. Okay, Korea. So Lavi, you want which one? Himalaya, space, Halloween, or underwater?
I want Halloween.
Okay, let's actually do Halloween. Okay, we'll wait for you guys. 11 of you should be there. Only one connected. You need to press start. Okay. So we wait for everyone. 1, 2, 3, 4, 5, 6, 7, 8. 3 more. One more. Okay, all 11 are there. So I'm going to actually start now. Okay, there is going to be the time limit over there. So please actually do it as soon as possible. So I'm going to click start now. Okay, I'm waiting for players. Let's actually wait for 11. Still waiting. Hurry up. 10. So one more. Aneta, are you already in?
Yes, sir.
One more person is missing. It's okay. I think Jody is having issues. Okay, we will start.
Already inside, sir.
Already inside. So who's not inside? Aneta is already inside. It's okay. Okay, we will start now. Jason is leading now. Okay, done. Okay, you can see your results over there. Jason is leading. Congratulations. Number 2, Arnetta, followed by Nicole, Trisha. Maybe next time. Okay. One. Also, everyone joined today. Okay, maybe Justin was having difficulty in the in joining the quiz just now. Anyway, so guys, okay, I hope you understand today's lesson. Okay, so is there any question that you want to ask before I end the lesson today? Victoria, any question?
No, sir.
Okay, that's it, guys. Okay, so if you all this lesson will be recorded, you can always actually check as usual in the BBS PIC channel. Okay, so that's it, guys. Okay, so see you. Bye. See you. Thank you, Mr. Sami. Thank you, Mr. Rufus. Thank you, Mr. Sheikh.
Thank you, Mr. Gopi.
Yeah.
Thank you.
Bye. Thank you.
See you. Bye.